Good evening. Today's quote is good one. It doesn't matter how slowly you go as long as you do not stop. It doesn't matter how slowly you go as long as you do not stop. Today's word is rendezvous, a meeting that you have arranged with somebody, a place where people often meet. The cafe is a popular rendezvous for students. Now, let us discuss a few important properties of union and intersection. Yesterday, we discussed definition of set, different types of sets, etc. Properties of union and intersection. If A, B, C are any three sets, then A union phi is A, obviously. A intersection phi, phi means null set, is phi. Then A union universal set is obviously universal set. A intersection universal set is obviously A. A union B is B union A. A intersection B is B intersection A. Don't say obviously, this is commutative law. A union A is A. In A intersection A is A. It is called as idempotent law. Now fifth part is very, very important. A union B union C is A union B. I'm sorry. Uh, this is important, but not that important. In the sense I was talking about, yes, this distributive property. This is one of the most important properties. Nevertheless, A union B union C is what? A union B union C. And A intersection B intersection C is what? A intersection B intersection C. This is called as associative law. If A is subset of B, then what is A union B? B. What is A intersection B? A. If A is subset of A union B, then B is also subset of A union B. And A intersection B is definitely subset of A. A intersection B is definitely subset of B, obviously. Because in intersection, we consider elements which are common. Yes, this is very, very important. Distributive property of union and intersection. If ABC belong to R, we know that A into B plus C is A into B plus A into C. This is known as distributive property of multiplication over addition. In set theory, the operation of union and intersection of sets are both distributive over each other. If A, B, C are any three sets, then A union B intersection C is what? A union B intersection A union C. Not only that, in many cases you get RHS, and from that you should be able to write LHS. Okay. How will you describe this in words? Union distributes over intersection. Union distributes over intersection. Similarly, intersection will distribute over union. So A intersection B union C will be A intersection B union A intersection C. Similarly, A intersection B union A intersection C is A intersection B union C. Now we will verify this using Venn diagram. This is interesting. The shaded portion in each figure shows the set obtained by performing the operation given below in the figure. B intersection C. Intersection means common elements. Now it's union with A. Union means all elements in A and all elements in B intersection C. One element is to be considered once only. This is not at all difficult. Now, this is A union B. This is A union C. And their intersection. Intersection means common part, common elements. Yes. Now you will notice that shaded portions in 2 and 5 are the same. See, this is 5 and this is 2. Yes, they are the same. And therefore, we can say that A union B intersection C is A union B intersection A union C. Please do write this after the lecture. This can be asked in exam, that prove distributive laws using Venn diagram. I think in exercise 5.1, we are going to verify these by considering few elements. Now, next one. This is B union C. Now, this is intersection of B union C with A. The elements which are common, which are in set A and in B union C. So, this part, okay. Next, this is A intersection B, elements which are common to both sets A and B. This is A intersection C, their union. See, this region, shaded region is the same as this one. So I can say that the shaded portions in figures 2 and 5 are the same. Hence, the sets represented by them are equal. This proves second distributive law that intersection distributes over union. Now this is very interesting. De Morgan's laws. If A and B are two subsets of a universal set X, then how will you read this? Complement of union. Complement of union is what? Intersection of complements. Second, complement of intersection is what? Union of complement. That is A union B complement is A complement intersection B complement. And A intersection B complement is A complement union B complement. These are called as De Morgan's laws. Now we verify this by considering these sets. Let X be the universal set. I hope you remember the definition of universal set. Any non-empty set of which all the sets under consideration are subsets can be considered as universal set. Don't say that only 6 elements. How can we say that it is universal set? Consider A and B. So the sets under consideration are subsets of X. So yes, this can be considered as universal set. This is very interesting. And the most importantly, not difficult, simple one. What is A union B? 1, 2, 5, 6 union 3, 4, 5, 6. That is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. So what is A union B complement? All elements in the universal set which are not in A union B. There is not a single element. So it is 5. What is A dash? Elements which are not in A but which are in universal set. 3 is not in A but is in X. Same for 4. So A dash 3, 4. What is B dash? Elements which are not in B but are in universal set 1 and 2. Their intersection, not a single element is common. See, RHS are same, so LHS must be the same. So A union B complement is A complement, intersection B complement. That is, complement of union is intersection of complements. Let us verify second law also. A intersection B, common elements 5, 6. What is the complement? Elements which are not in A intersection B but are present in X. Those elements are 1, 2, 3, 4. What is A dash? 3, 4. What is B dash? 1, 2. What is their union? 1, 2, 3, 4. Are these two sets equal? Yes, they are. So A intersection B complement is A complement union B complement. This is Morgan's second law. Now you will read this, then I'll explain. Now this is an interesting concept, difference of two sets. If A and B are two sets, then the difference A minus B is the set of all elements of A which are not in B. So A minus B is defined as all X. How to read this? Such that X belongs to A and X does not belong to B. If A is 1, 2, 3, 4, B is 2, 4, 6, then what is A minus B? Can I consider 1? Yes. Can I consider 2? No. It belongs to B. 3? Yes. It doesn't belong to B. 4? No, because it belongs to B. So A minus B, 1 minus 3. See, don't say B minus A, take minus n common, not in that sense. So what is B minus A? elements in B which are not in A, only one element. Now see the Venn diagram. This portion is shaded because A but not B. See, A but means and. A and not B. And what about this? B and not A. Okay. Now common sense, A minus B is a subset of A and B minus A subset of B. The sets A minus B, see this is A minus B, this is B minus A, and this common region is what? A intersection B. They are mutually disjoint sets, obviously, because if an element is in A minus B, it will not be in B minus A. Again, it will not be, see the cursor, in A intersection B. So they are disjoint sets, their intersection is null set. Now this is interesting. A minus B. I have already explained this. How will you describe A minus B? A but not B. But means and not B means B dash. See, A and B dash. Similarly, what is B minus A? B but not A. Means not A means A dash. So A dash intersection B. And finally, what is A union B? See the diagram, this complete part. So A union B comprises of A minus B, A intersection B, B minus A. Now, just remember the definition. A minus B union B minus A. How to read this? A delta B or A symmetric difference B. So A delta B is called symmetric difference of sets A and B. In exam, you may be asked to find A delta B. Suppose this is A, this is B. So what is A minus B? 1, 2. What is B minus A? 5, 6. So their union means what? Occurrence of exactly one of the two. So that is difference of, rather symmetric difference of sets. Now exercise 5.1. Describe the following sets in set builder form. The first one, let set AB, singleton set 0. Now here I have written all x such that x is a whole number, but x is not a natural number because 0 is the only whole number which is not a natural number. Or you may say that 0 is an integer lying between -1 and 1. Or you may say the only integer which is neither negative nor positive, or only real number, whatever. Okay, but this definition is sufficient. This is the first part. Write down. Now second part, 0 plus minus 1 plus minus 2 plus minus 3. That's it. This is the finite set. Okay. So how will you describe this? Now you will notice I say that this is set B. Okay. So B is the set. I can see that this is set of integers from -3 to 3. Do you agree with me? So I can say that set of all x such that x is an integer denoted by z or by I, such that -3 less than or equal to x less than or equal to 3. Write down. Third one, let C be the set 1 by 2, 2 by 5, 3 by 10, 4 by 17, 5 by 26, 6 by 37, 7 by 50. Now, numerators are consecutive natural numbers. And what about denominator? It is numerator square plus 1. So I can say set of all x such that x is n upon n square plus 1. N is a natural number, but this is finite set. So n is less than 8 or n is less than or equal to 7. Set D, 0, -1, 2, -3, 4, -5, 6. So even integers, I'm sorry, 0 to 4, 6 have positive signs, and odd integers 1, 3, 5 have negative signs. So can I say D all x such that x equal to -1 raised to n minus 1 into n minus 1, where n is natural number. Check, put n equal to 1, first natural number. So it is 0 present. Then put n equal to 2 minus 1 raised to 2 minus 1 is basically what is minus 1 raised to 1? It is minus 1. 2 minus 1 is 1. Minus 1. Yes. And so on. So this is how we can represent set D. Question 3. If A is set of all x such that 6x square plus x minus 15 equal to 0. B set of all x such that 2x square minus 5x minus 3 equal to 0. C is set of all x such that 2x square minus x minus 3 equal to 0. Then find A union B union C, A intersection B intersection C. Basically, we have to solve quadratic equations. Now, 6x square plus x minus 15 equal to 0. You have to split middle term x as minus 9x plus 10x. Why like this only? I hope you know how to solve quadratic equation by factorization method. 6 into minus 15 minus 90. Split minus 90 into two numbers so that their product is minus 90 and their sum is x. So minus 9 plus 10. Okay. Now what does SS stand for? Solution set. Solution set of this equation is A equal to minus 5 by 3, 3 by 2. Now B, set of all x such that 2x square minus 5x minus 3 equal to 0. Now, can you tell me the factors of this? 2x square minus 5x minus 3 equal to 0. Split middle term as what? Minus 6x plus x. Okay, so can I say that roots are 2x minus 1? So I can say x equal to, just check this, minus half and other root is 3. Yes. Therefore, B is minus half comma 3. See, order is immaterial. I should not say that write minus half first and after that 3. Not necessarily. Order is immaterial. Please check the factors. And what about C? Set of all x such that 2x square minus x minus 3 equal to 0. Tell me what are the factors. Middle term should be written as what? Minus 3x plus 2x. So I'll write factors if you want. Factors will be x plus 1, 2x minus 3. Is it? Just check this. I have written directly, but these are correct factors. So x equal to minus 1, x equal to 3 by 2. So what is set C? Minus 1, 3 by 2. Yes, what is asked? So A union B union C. So one element is to be written once. Actually, it is better if we mention all the sets and then find their union. But I am writing directly minus 5 by 3, then 3 by 2, then minus half, 3, minus 1. See, one element is to be written once only. I hope this is clear to you. 3 by 2 occurs twice. 3 by 2 is present in set A and set C also. But it is to be written once. Now, this set is the same as which set? I repeat, you need not write in this order. But what I have written is also correct. Because when I say order is immaterial, this is also correct. In exam, for this also you will get full marks. Now, second part, the elements which are common to all the three sets. Not a single element is common. So that is null set, empty set. Fourth one, if ABC are the sets of letters in the words college, marriage and luggage respectively, verify that A minus B union C is A minus B intersection A minus C. Now, set A is set of letters of the word college, COLEG. That's it. One letter is to be written once only. B, set of letters of the word marriage, MARIGE. C, set of letters of the word luggage, LUGAE. That's it. Now, what is B union C? In exam, you can directly write this, but here they have mentioned first B and then union C. And what is the union? MARIGELU. And what is A minus B union C? All letters in the set A which are not in B union C. Only two letters, C, O. So this is number one. Now it is A minus B. All letters or all elements, I should say, all elements in set A which are not in B. It is better if you mention these two so that you can compare COL. What is A minus C? CO. Now what is their intersection? CO. Now from 1 and 2, it is clear that A minus B union C is A minus B intersection A minus C. Fifth one, if set A, B, C are given and universal set is given, then we are asked to prove 10 things, beginning with distributive law. A union B intersection C is A union B intersection A union C. Second, fourth and sixth for homework. So what is B intersection C? 4, 5, 6. Then it's union with A. 1, 2, 3, 4, 5, 6. A union B. 1, 2, 3, 4, 5, 6. A union C. All elements in A, all elements in C, but one element is to be written once only. So 1, 2, 3, 4, 5, 6, 7, 8. Now the intersection of these two. Now from 1 and 2 it is clear that A union B intersection C is A union B intersection A union C. You may write a note that this is distributive law. Third one, we have to verify Morgan's law that complement of A union B is A complement intersection B complement. This is A union B, 1, 2, 3, 4, 5, 6. Now in complement of that, we have to consider elements which are not in A union B, but are in universal set. They are 7, 8, 9, 10. This is A dash, this is B dash. Their intersection is again 7, 8, 9, 10. So from 1 and 2, A union B complement is A complement intersection B complement. If possible, write note. This is Morgan's law, De Morgan's law. Fifth one, what is A intersection B? Elements which are common to two sets A and B, 3, 4. What is B dash? 1, 2, 7, 8, 9, 10. So what is A intersection B dash? A intersection B dash is 1, 2. So A intersection B union A intersection B dash 1, 2, 3, 4. But this is nothing but given set A. So what is A? A intersection B union A intersection B dash. So set A comprises of two parts, elements which are only in A. How to read this? A but not B, and elements which are common to both A and B. Next, A union B, 1, 2, 3, 4, 5, 6, A minus B, elements which are in A but not in B, 1, 2. A intersection B, common, 3, 4. B minus A, elements which are in B but not in A, 5, 6. Their union, 1, 2, 3, 4, 5, 6. So from 1 and 2, A union B is A minus B, elements which are only in A, union, common elements, union, elements which are only in B. Sum number 8, B minus C is 3, C minus B is 7, 8. So B symmetric difference C or B delta C is, as per definition, B minus C union C minus B. In short, this is occurrence of exactly one of the two. The elements which are present in exactly one of the two sets. So they are 3, 7, 8. So common are to be excluded. Now its intersection with set A, 3. A intersection B, 3, 4. A intersection C, 4. Now the difference, A intersection B difference with A intersection C, 3. Now A intersection C difference A intersection B. So all elements in A intersection C which are not in A intersection B. Now 4 is the only element which is present in this set. So null set. Now what is A intersection B delta A intersection C? This union this. That is again 3. So from 1 and 2, A intersection B delta C is A intersection B delta A intersection C. Now ninth one, n of A is 4, n of B is 4. Don't say n of A union B is 8 because one element is to be considered once only. See, A union B, 6 elements. So n of A union B, 6. What is A intersection B? 3, 4. So n of A intersection B, 2. So Na plus nb minus n of A intersection B. 4 plus 4 minus 2, that is 6, which is nothing but n of A union B. Now 10th one, what is n of B? It is 4. Then what is A dash? You cannot write n of A dash directly unless you write that set 5, 6, 7, 8, 9, 10. So n of A dash okay, n of A dash is not required. I'm sorry. So we have to consider its intersection with set B. Okay. So what is A dash intersection B? Two elements are common. So n of A dash intersection B is 2. We are interested in this. What is A intersection B? Elements which are common. So 1, 2, 3, 4, 3, 4, 5, 6. Just check this 3, 4. These are the only two common elements. So n of A intersection B is nothing but 2. So n of A dash intersection B plus n of A intersection B is 2 plus 2, 4, which is n of B. See, this is quite logical. If you consider Venn diagram, I haven't drawn that, but set B consists of two parts, elements which are present in only B. Because how will you read this? B but not A, and elements which are common, right? So that's it.